Hey everybody, welcome back to the Electronics Workshop. I'm Justin. Hi. My call sign is KC9WSC. I have a nerdy little space in my home basement workshop that I tinker with a lot of electrical things, and amateur radio equipment is a large part of that. Yeah. So I've had a couple of things that have happened recently in my electronics personal hobbyist career that has led me to kind of evaluate my equipment, see if I would like to potentially get rid of some stuff. So mainly that is I've gotten a new communications analyzer that I have no right to own because it's clutter. I don't deserve it. I'm not worthy. I'm not worthy. I am scum. Anyway, I ended up getting something pretty awesome. It's actually a Freedom Communications Technologies unit that will be showing up in some other videos, but not quite yet. It's phenomenal. There's so many features. There's so much I can do with that. It is probably worth more than my car, unfortunately and sadly. So again, I don't really deserve to have this thing. But what I do want to show is a few things I've been kind of coming to a conclusion with is for me to kind of move forward with my radio repair things that I do, and space being a major concern. There is some equipment that I'm probably not going to need. But in the meantime, I figure why not do a video with some of the things that I do have, and that being, which is right behind this camera, which I will flip around and show you, is a beautiful, beautiful piece of communications analyzing equipment from about the late 80s. So it's actually a little younger than me, believe it or not. Yeah, I know. I'm getting grayer. I don't like it. Whatever. So let's take a look at it. All right, so here we have it. And I'm sure some of you are probably fairly familiar with Marconi equipment. It's actually some really, really top-notch stuff from back in the day. And even today, it's actually an extremely useful piece of equipment for amateur radio folks who are looking for something fairly affordable that isn't going to quite break the bank on, dealing with your radio equipment. Or let's just say you're in an amateur radio club and your responsibilities in that club as a member is going to be servicing the beautiful equipment that you have, and some of those are going to be probably repeaters. So this will at least get you kind of a leg up on verifying your equipment's functionality and calibration and a lot of other things. So but anyway, we're going to do some testing with this piece of equipment. This is the Marconi Radio Communications Test Set 2955. So it's a pretty good thing. It's not the B, it's not the, I think they made a C version. I think this might be the A. There are some things that are different on it than others. I do notice that there's a sticker on here that says 100 watts max. That's not normal. That is kind of leading me to believe that this one may have been updated or upgraded for certain things, for higher power handling. I'd probably still stick with maybe about 50 to 75 watts just to be safe. But I think the unit will scream at you if you're exceeding and it's getting too hot. So you have your high power port here for your RF in, RF out. You have your more sensitive, lower powered version here. That's 0 to 5 watts. Again, I still wouldn't plug an HT into this, just because, that I use that for the more sensitive things. There's less protection on this port, whereas the N-Type 1 has a little bit more protection, kind of just in its design. Easy to select between the two ports by just hitting select, and it switches over a little relay that goes between. Pretty awesome. You have some audio frequency generator capabilities. You have your audio frequency input stuff. I think this would be kind of used for some SUNAD testing. You can external modulation testing you can do from it. There's a whole lot. I mean, easy to navigate stuff. There's an oscilloscope function that you can use on here to a certain degree for some certain like testing functions. If you're on site and you need to get an oscilloscope for any reason, you can kind of pull this up. It's probably not the most feature-packed oscilloscope, being that you don't really have a whole lot going on here, but it's there. In a pinch, it'll definitely do you good. AC/DC, I'm not sure if this has to do with maybe multimeter function, possibly, I don't know. But we want to focus on radio communications testing, and for that we're going to need a cable. And for that I have a pre-made jumper, apparently that was made by Wireless Solutions. Again, goodness gracious, focus. Are you kidding me? Do I have to click it on auto? It's not going to do it anyway. Cameras. This is it's made by Wireless Solutions. It's a pre-made cable. It's using some pretty good stuff. Belden, 90, 83, 40, 83, I don't know, I can't quite read it, but I know it's good stuff. So let's go ahead and just hook it up. I'm gonna act like I know what I'm talking about. And for the test subject, we're gonna use this FT5D that I have. It's been a pretty nice little radio, although I'm still I don't use it often enough. So it's kind of one of those deals where I should probably use my radios instead of letting them sit around. So just get the cable plugged into that. As you can see, we are connected. And as you can see, we are currently on the standard FM simplex calling frequency. Let's not go on there. Let's try something different. Let's do 145 megahertz. And what we need to do now is we need to configure our test set. So we're going to do transmitter testing. And let's go ahead and select our frequency of 145.000 meg. Groovy. We're there. This cable is pretty stiff. It's not gonna, and then of course it's gonna be right in the middle of the camera, so of course. I'll try to not make that noodle get in the way too often, but I'll do my best. So we are currently set up on the frequency of interest, and the device under test is connected. So let's go ahead and just do the bar graph, because I want to see power, I want to see deviation, and we can also see that there's power up here, modulated mod frequency, and level. So let's just go ahead, and I got my filter set to 0.3 to 3.4 kilohertz. And, you know, to keep things nice and legal in the amateur radio space, I will ID. I mean, I'm in a basement, and I'm going into the radio's test set, which has a dummy load. Chances are any RF that is coming out of this is so weak, it's not going to go anywhere. Plus, like I said, I'm in a basement, and I live in the country. But we'll keep it legal. Hello, 1, 2, 3, 4. This is KC9WSC. Hello, 1, 2, 3, 4. And let's see what the deviation is. Hello, audio. Yeah, it's pretty good. I'm really up on the microphone though, and that's kind of one of those things that has driven me a little nuts about this radio is how close you have to get to the microphone to get the deviation to be within a reasonable level. And I already do have it turned up to a 9, and it is running on wide, so it's kind of a little bit of a quieter microphone, sadly. On the peaks it does come up quite a bit, but you do have to be about 1 inch away, and unfortunately when you get that close to a microphone, sometimes you get the puffing of air, and that's a pet peeve of mine. Pet peeve. Anyway, KC9WSC, hello, 1, 2, 3, 4, audio 1, 2, 3, 4, KC9WSC. So there you have it, and we can see it was doing, decent RF power. A little bit of loss through the coax, I'm assuming. So all intents and purposes, it's probably about a 5-watt capable radio, and we're getting 4.4 out. I'd say that is a pretty good sign that that radio is working quite well. You can actually also listen to your modulated audio on this, which is handy, of course. So we'll go over here. Hello, 1, 2, 3, 4. Oh my God. And this is kind of the downfall of this test set. The internal speaker is pretty bad, KC9WSC. Yeah, the speaker is not great. It's very tinny on the best of days. So it's really there just to let you know, yeah, there's audio. I can hear it. But, okay. You're getting your Bose audio out of this. Let's just say Bose audio. No highs, low lows. This is all highs. I'm done. Anyway, let's go back and let's look at RX. Let's look at the receiver capabilities. So this is kind of another thing that you really want to check is how sensitive is this darn thing, and let's figure out a way to show that potentially, maybe on camera, possibly. Oh my goodness, floundering. This is turning into a disaster. I should have gone with a different cable. Can I do this? Can I do anything right? Oh my goodness. This is terrible for coax. Don't do that, but I'm doing it. Okay. Adjust the camera. Maybe we'll... Sure. This is not too close. That's better. Okay, so now we got the camera in focus at least. So on the test set, let's go ahead and do some testing. We're already generating a signal, so we are going to navigate to RF Gen, and then we're going to navigate to, we have already on frequency, so we don't have to worry about that. But now we're going to use the level, which is going to be the level of RF we're generating. And we'll see what it takes to open up this receiver without a tone, without any modulation. It just opens up at negative 125.6-ish. Let's just say about a negative 125 dBm is about where it's happy. All right. And now we're running some tones through it. There's a pulsing tone. And let's adjust that till we hear it sound clean without that hiss. Hiss is almost gone. And that is a full quieting signal right there at negative 100 dBm exactly. That's pretty good. That is pretty good. And then we're going full scale plus here, where we're getting all red bars are completely full. And let's just say it's at about negative 92 dBm. So, not bad. Good little receiver on that radio. Okay, I'll go back to transmit. So yeah, you can do some basic receiver testing on it to just get an idea of how sensitive your receiver is. And this one seems to be very good. Very happy to see that. But that doesn't really test some of the other issues where receivers can get desensed from RF that's close by. So there are some other ways of testing that on with using this piece of equipment that you could maybe feed in some outside interference to kind of simulate that. But this also does some other functions that are pretty awesome. So if we go to tones, you can do a two-tone. Looks like you can do some other stuff here. Looks like CCIR. I'm not familiar with it. Let's just go back. Let's go to tones. Tones. Let's go back. Tones. There we go. Two-tone. If we go to receiver, navigate back. Go to receiver, and then we go to tones. We can do our sub-audible tones. So you set that up here. So the frequency currently is on 150 hertz. The FM level for that is at 500 hertz. And the audible tone modulation is at 1 kilohertz now. So you can set your mod level. So about 500 is pretty standard, so I can see why that would be there. And then when you're ready to send that tone, you just click send, and it sends it, turns it on and off. So anyway, another fun feature, duplex capabilities. If you are working on two radios, a transmitter and a receiver, say it's a repeater, you can configure this test set to work with a repeater itself using both ports on here. So this port specifically would be your transmitter input, and then the B and C would be your receiver. So what you can do is you can feed a signal in through to your receiver, say the frequency, the subaudible tone, and kind of test the transmitter and the receiver together and make sure that they're jiving. I don't think you can do a duplexer on this. You can do some testing with a duplexer, like say you want to figure out maybe how much dB you're losing, how much loss you're having in your transmit. You can sample your transmitter's output power and then sample your duplexer power output with the transmitted signal, and then figure out how much you're losing internally in the duplexer and your cables, etc. Same thing with the receiver. You can test that. You put your transmitter in standby mode or turn it off, and then feed the signal into the transmitter using the same method of backfeeding the duplexer and taking note of that number that it takes for certain things. Say you're doing some SINAD work, you can actually connect it up and get a more accurate reading. Or if you do it by ear, you can get a pretty darn good reading on where things are. I prefer doing the SINAD because if you're documenting any type of receiver performance within a club, you can have hard numbers that you can give people. You write down, say, I used this piece of test equipment and it was done on this date, blah, blah, blah. Good note keeping, good record keeping for your equipment. Very, very good idea as well. Okay, so yeah, there's a lot you can do with this. And I just don't use it very often, unfortunately. This isn't the one that I take out often enough to justify me maybe keeping it. So I'm probably going to be doing a little bit of hard thinking on, do I keep this one? Do I send it down the road to somebody else who can have a better use for it? Maybe an amateur radio club locally, excuse me, is looking for something to manage their equipment. I can strike a deal with them, because the money that I'm going to generate from getting rid of this, I need to put into that Freedom communications test set to have it recertified, as well as maybe have a little bit of work done to it, because I think I may have run across a problem. That's likely why I got it. So there's going to be a repair most likely needed to get that thing up to full spec. And I've got some other communications equipment that I'm not going to need nearly as much now, if at all, so I may have to put together another list. So at this point, it's not for sale, but we'll see. I hope you guys enjoyed this nerdy video of me going through and just kind of demonstrating some of the procedures you take when you're testing out radio equipment, and also showing the Marconi Instruments Radio Communications Test Set 2955. It's a legendary thing. Marconi made some pretty nice stuff, and there were other companies that took over the Marconi name and made their own. So there's a few other pieces of equipment that look similar, same exact thing, different name, different owners. Anyway, hope you found this fun, hope you found this informational, and most of all, hope you enjoyed this nerdy moment. We'll catch you again. 7-3 for now.